So here we've got this example where three charges A, B and C are arranged as shown. The magnitude of the force on C on A is 2 newtons west. Okay, so A is exerting, that's the word, hey? Is exerting a force on A as 2 newtons west. Okay, so I'm going to put this in there. So that's 2 newtons west. That NW is not for northwest, it's 2 newtons west, right? And then it says the magnitude of the force of B on A is 3 newtons north. Okay. Right, and we've got to find the resultant force experienced by A. Now, when we have two vectors that are perpendicular to each other and we want to find the resultant, we can easily just go and add them tip to tail. So I'm going to first do this one, 2 newtons this way, and then if I draw a tip to tail with the 3 newton vector, it's going to look like that. And these are now perpendicular to each other. And then we know that the resultant vector is the one that starts at the start of the first one and ends at the end of the second one, right? So this is going to be our F res or F net, whatever you want to call it, right? And now because we have a right angle triangle and we already have two of the sides, we can use Pythagoras in order to find the next one. Right, so we're going to say that the F res squared is equal to the 3 squared plus 2 squared, which means that the F res, or F net again, is going to be the root of 3 squared plus 2 squared. And then again, I'm going to use my calculator. So 3 squared plus 2 squared is equal to root 13. Okay, so that's then going to be root 13 newtons. But since we're doing science, we tend to like to put things in decimals. Easier for us to wrap our heads around that, and that's going to be 3,61 newtons. Okay, and then if you are asked to give a direction, what you'll have to do is put theta there as that angle, and then use the following: tan theta is equal to 3 over 2, and then go, okay, tan -1 of the 3 over 2 equals theta in order to find that theta, and then you can use that angle in order to indicate the direction. Okay, so what I'm going to do now is I'm going to pause the video and then you are going to try the following. So well done on giving that a try. If you can answer this question, you can answer any Coulomb's law question. Let's see. So you've got the three charges A, B, and C. They're arranged as shown. The charge on A is 1 nanocoulomb. The charge on C is -2 nanocoulombs. And the charge on B is positive 4 nanocoulombs. And we want to find the F net that's being acting on A. Right. So A is positive, C is negative. That's going to be attraction. So the force on A due to C is going to be towards the right, and then B is positive and A is positive, so that's going to be repulsion. So the force on A due to B is going to be upwards like that. So then we have to use Coulomb's law as before. So F is equal to KQ1 Q2 over R squared, and I'm just going to save us some time, and I'm going to just write this down. 9 times 10 to the 9 times 1 times 10 to the -9 times 2 times 10 to the -9, and then that is divided by 0.02 squared, because I've got to change the centimeters to meters, and that's going to be 9 times 10 to the 9 times 1 times 10 to the -9 times 2 times 10 to the -9, and then 0.02 squared. Okay. Right, so if all went well, this should be the answer, which is then 4.5 times 10 to the -5 newtons. Okay, so that's then the magnitude of this force over here, which we know is towards the right. Then to find the other one, we've got to do Coulomb's law again, 9 times 10 to the 9, times, again, the 1 times 10 to the -9, because nano, times 4 times 10 to the -9. Now for B, and we've got to divide now by 0.04 squared, because it's the 4 centimeters there. And let's see what our calculators give us. So I've got the 0.04 there, and then I'm just going to change this 2 to a 4. And I get that we have 2.25 times 10 to the -5 up. Okay, 2.25 times 10 to the -5 newtons. and this is going to be upwards. Okay, cool. So now I'm in luck. I know the magnitude of both of these, which means I can now go add them together tip to tail in order to find the resultant. So here, this one to the right is the 4.5 times 10 to the negative 5. And then I know I've got to add tip to tail. So the tail of one goes to where the tip of the other was. Something like that, and that's the 2.25 times 10 to the negative 5. Okay, I've drawn this a bit silly because my longer vector actually has a smaller magnitude, but that's fine. Won't affect the result. So I'm trying to find f-res. Okay, so again, I'm just going to use Pythagoras. So the f-res is going to be equal to the root of this 4.5 times 10 to the negative 5 squared plus the 2.25 that's not a 5, times 10 to the negative 5 squared, and then let's see what we get there. Right, so root of 4.5 times 10 to the negative 5, which we are going to square, plus underneath that square root sign still the 2.25 times 10 to the negative 5, which we again going to square, and so I get here an answer of 5,03 times 10 to the negative 5 newtons. And we were just asked for the magnitude, so I don't have to give the direction, and that's what we ended up with there. So well done if you got that correct. This question would be out of a few marks, but it's all doing simple things that have added together to give something a little bit more complex. But you just did Coulomb's law, identified a direction from attraction or repulsion, then found a resultant force, which is something we should be able to do from physics, and that was it. Something complicated can be broken down into simple steps. Let's keep going.